I'm going to solve the third partial exam of electricity and magnetism. We have a circuit that is something like this. Here we have a capacitor, and here we have another capacitor, but here we have a switch, and here we have our battery. Here is the positive part and here is the negative part. We know that our battery is 12 volts and our capacitor 1 and capacitor 2 is of 500 picofarads. We have to determine the energy delivered by the battery first, then we have to determine the energy stored in the capacitor 1, and then the switch is thrown from A to B. So the circuit is allowed to reach equilibrium, and then we have to find the total energy stored at C1 and C2, and then explain the energy lost in if there is any one. So first I'm going to do the first part, that is the energy delivered by the battery. For understanding this part, we have to consider that the charge is equal to the capacitance times the voltage, that is the battery, and the energy, potential energy, that is the energy delivered, is equal to the charge times the voltage. So the charge, as we said, is equal to the capacitance times the voltage, but we are only using the first one because it's closed in A, so we are using only the first one, and this is multiplied by the voltage. This will be equal to the 500 picofarads, that is this part, times our voltage square, that is 12, because it's voltage times voltage is voltage square, so 12 squared, because we said that it was 12 here. So once we solve this part, we will obtain that the potential energy, so the energy delivered, is equal to 7.2 times 10 to the minus 8 joules. This is for part A. For part B, we said that the energy stored in C1. So here we have this same system, and we want to obtain this energy stored in C1. So for solving this part, we know that the potential energy, so the energy stored, is equal to 1/2 of the capacitance in the system, that is C1, times our voltage square. So we only substitute this half here and the 500 picofarads here, and the voltage square here. And this is equal to 3.6 times 10 to the minus 8 joules. And this is the answer for letter B. Now for letter C, I'm going to solve it here. We are asked to obtain the total energy stored at C1 and C2. So now the switch is here, so now there is an equilibrium in the system. So we know that the voltage 1 will be equal to the voltage 2 because it's the same voltage throughout all the system. So as we know, the voltage is equal to the charge over the capacitance. So this is equal to say that the charge 1 over the capacitor 1 is equal to the charge 2 over the capacitance 2. Okay? And then if we want to obtain the original charge of the capacitance 1, we are going to write it like this, the charge 0. So this will be equal to our charge 1 plus our charge 2, because now the system is connected. So once we denotate this part, we can use this other part here to obtain our charge 2, that it's equal to capacitance 2 over capacitance 1, this one over this one, times this one, times our charge 1. And then we go back to this part. So our original charge, it's equal to the charge 1, that is this one, plus, well, we factorize it, the charge, and it's 1 plus, but our charge 2 is this one. So we can put this part here, that is the capacitance 2 over the capacitance 1. So here we factorize it, the capacitance 1, we take it out, and we use these terms in here. Okay? Once we know this part, we can reuse this expression that the capacitance, the charge is equal to the capacitance times the voltage, and then we can say that the capacitance 1 times the voltage, that is this part, it's equal to exactly this part in here. Once we are denotating this part in here, we know that only we have to substitute, because we can know the values right now. So we know that our capacitance 1 is 500 picofarads, our voltage is 12 times 12. This is equal to our charge 1 times 1 plus 500 over 500. And this is equal to 2, because it's 1 times 1, 1 plus 1, it's equal to 2. And this part in here is equal to 6 times 10 to the minus 9, because this is in picofarads, okay? So now we know this part. I'm going to continue in here. So once we have this is the only variable that we don't know. So we have to get it out of the expression, and we can obtain that the charge 1 is equal to 3 times 10 to the minus 9, because this part goes divided in here, so it's 2 over this part, and is this part. And now once we know this one, we can obtain the charge 2 by substituting in here. So the charge 2 is equal to 500 over 500, because it's charge 1 charge it's from substituting in here, sorry. Charge the capacitance 2 over capacitance 1 over times the charge 1, that is this part, and now we can obtain the charge 2, and the charge 2 is equal to 3 times 10 to the minus 9, so we can see that it's exactly the same one, these two. Once we know this, we can obtain that our potential energy is equal to 1/2 of our charge 1 squared over the capacitance 1, as the formula said, and this is equal to 1/2 of the charge 1, that is 3 times 10 to the minus 9 squared, over our capacitance 1, that is 5 picofarads, and this is equal to 9 times 10 to the minus 9 joules. Okay, and this is for part C. For part D, we have to explain the energy lost, if there is any. So I'm going to write it here. So the energy lost is the difference of energy. So the energy lost is 2 times the voltage in 1 minus the original voltage. And this is equal to 1.8 times 10 to the minus 8 joules. Why? Because the energy is divided, the original supply of energy is divided in at half at the beginning of the hard supply in here, and then when the switch is divided, we have another division. So this is why we are dividing the battery into two parts. So this is why we divide the original into two parts, and this is how you solve the first problem of the third partial exam.